I'm going to focus a bit different. Dynamic source manufacturing, we don't have any products. All we do is manufacture products for other customers. So I'm not going to talk about a specific product. I'm going to take you through kind of what we envision of a perfect new product introduction scenario. So bringing products to market. Give you a bit of an overview of who DSM is. We're basically in our 11th year of business right now. Just over 100 employees. What we really pride ourselves on is providing a customized manufacturing solution. We realize that every customer is unique, every customer has different products, and we kind of tailor our services around what the customer is looking for, not trying to fit them into a shoebox kind of solution. So we can offer everything from full turnkey box build right through to final logistics, shipping to year-end customer. We are ISO 9001 and 1345, which is medical device manufacturing standard. And our primary markets that we look after are oil and gas, communications, medical, military, and industrial control. Right now we're operating at a 30,000 square foot facility in Northeast Calgary. We have 5 SMT lines, we've got a quick turn prototype line, and 4 high-speed volume lines. Each of our lines has automated optical inspection built into each of the lines. We do through-hole assembly, automated through wave solder and a selective-based laser soldering solution. As mentioned, we can take through complete enclosure assembly, box build, final packaging, and shipping. One thing we launched about a year ago was a warranty and off-warranty repair center for some of our customers that have operations in the US or offshore. Instead of sending products cross-border, we can bring them in-house and repair them in-country. We do have a Class 10,000 clean room in our facility as well. And we can offer full GTAG test development, functional test development solutions, including fixturing. Also help through environmental life cycle testing as well through one of our partners. Specific to the new product introduction, we do have one dedicated quick turn prototype division within our company. So it has its own standalone line, its own people for manual assembly. And our standard turn is a 5-day turn for manufacturing. We do offer a 3-day and a 24-hour turn, which is not nice, but we do it. So we do offer a formal NPI project management team, so we can help you take you through the initial concept of the design. Here's your design, help you build up your BOM structure, point out items that we see as inefficiencies, maybe in the design for manufacturing, and provide feedback from that standpoint, and take it right through to a volume product with you. And we do that through the design for manufacturability and design for test as well. 2 key processes that are available through us. Basically, what we're trying to do is design in the best cost initially in the prototype phase, offering full turnkey services and full supply chain management as well. So on design for manufacturability side, our philosophy with prototyping is twofold. We want to prove, and obviously, the concept of design, what you guys have designed, make sure it works. We also want to prove that the device is manufacturable as well. Anyone can actually solder, I shouldn't say anyone, but most people can probably solder a device on a bench. It's going to work, you prove your design, but is that product actually manufacturable? It's a good question. So we like to do that right at the prototype phase, whether we're building a 5-piece build, a 10-piece build. We like to put it on our automated equipment and run it through that way, so we can see if there's issues with machine placement for certain devices, and can we actually build more than 10 of these. We see a lot of great designs and great products. Not all of them can ever be manufactured, though. We quite honestly reject a lot of business because devices can't be manufactured in a reliable manner. Specific to the energy industry, we do a lot of downhole tool applications. One thing that's really critical there is the repeatability manufacturing process. If we can't achieve that repeatability, it's very difficult to manufacture a product that's not going to have defects built into it. One of the keys there is these products cannot fail. Failure downhole is not an option for most of our customers. So some of the factors to consider with downhole applications, it was mentioned before, these things are in environments where temperature and stress are very high. Quite often the devices themselves are not rated to even operate in those environments. Designers will sometimes push these devices beyond their maximum ratings. And design layout issues really compounds the issue. It becomes an exponential issue where you start to design a bad land pattern, and these things, you're bound to see field failures at that point then. So one of the questions we ask as we bring a product to this, how do we actually build this? We've got a step so we go through with our customers. One thing we want to do is get involved early on in the design phase, not when you guys have a prototype ready to go, but basically do the design layout review, actually looking at the solder paste design of the stencil. There's things we can do to improve on land pattern issues. Part format, how we actually bring the material in, how we like to see the material come in, whether it be in a reel, as a bulk, and really pushing automation and assembly. That's one of our keys. We don't hand build any prototypes. It's all machine placed. And then we look at the data through the prototype phases, analyze the AOI yields, test yields, and then do a formal proto report at the end of that build for you. And that leads us into then developing that technology roadmap with that customer. Whether they're going to a package-on-package format or how we want to take this product to the next level, we can help the customer say, if you're going this direction, here's where we're heading, and we can kind of compare technology roadmaps from that standpoint. Biggest question is, why do we care? The result for the customer is basically you get a product that's ready to go to volume manufacturing in a prototype phase. We're designing in the optimal assembly cost for it, and we're getting a higher quality product in the end. And ultimately, that will result in lower field failures, which then results in a happy end customer. The result for us is not, we're completely not self-serving in this, so we want our customers to be successful, so if they're successful, we'll win with them. And what we're really looking to do with the customers, we bring in a new customer at DSM, we want a customer that has a similar philosophy as we do, that value the input we can give them from the prototype phase, and then take that into the volume as well. And basically lets us partner with them to provide really a customized solution and build a customer for the long term. And that's essentially the presentation.